All right, we're going to do a little bit of linear review. So for the following data, find the following: slope, y-intercept, equation, y-value when x equals 45, and x-intercept. So we have our data organized in a little table. And let's get cracking. So slope we have found. If we look at how these numbers are changing, we can extract some slope information from here. So this is a pair. So if we take that pair of information, and we say it's rising 4 while it's running 2, we get a slope of 2 over 1. If we take the next pair, we'll see that, hey, look, we get the exact same thing, a rise of 2 and a run of 1. So the slope here is 2 over 1. If we take advantage of knowing that slope is 2 over 1, we can work this problem backwards. So this has to change by 1. This has to change by 2. So that would get us to the 0 we're looking for, and that would get us to 3 for a y-value, which would mean our y-intercept is 0, 3. So the equation would be the combination of the slope and the y-intercept, so that would become 2x plus 3. Now the advantage of having the equation is when you want to find a y-value when x is 45, we can just take our equation, put in 45 for the x value, and calculate the y value. So in this case it would be 93. And then lastly, our x-intercept. If we wanted to find our x-intercept, again we can use our equation. So if we set x-intercept, they all have y values of 0. So if we take our equation, our original equation, and we set the y value to 0, now we just have to solve this little expression. Okay, so if we solve that, I'm going to subtract 3 from both sides, then divide both sides by 2, and I get the x value of negative 1.5, or negative 3 over 2, so the x-intercept is negative 3 over 2, comma 0. Okay, so what two items are needed to find the equation of the line? To find the equation of a line, we need slope, and we need any point. Okay, if we have a y-intercept, that's great, it's faster, but any point is all we need. So find the equation of the line that passes through 4, 6 and is parallel to y equals negative 2x minus 7. So we are looking for slope and point information, and is a connector word. So there's linking two ideas before and after. So there is point information here, which means somewhere over here we have to have some slope information. So if we look at parallel, that means the same slope. So this given line has a slope of negative 2, which means the parallel slope is also negative 2 because they have the same slope because they're parallel. So this piece of information and this piece of information become my slope and my point, and then I can do my algebra really quickly. So I write down my equation, I sub in my slope, I sub in my point, I solve for b, and I think I get, what, 14 for b, and then my equation becomes filling in the slope and the y-intercept. There's my equation. Cool. Okay, so graph the 3 lines below using the slope and y-intercept form. So state the slope and the y-intercept, that's always good practice. So the first one is in the correct form, so we should see that the slope is 3, the y-intercept is 0, negative 5. So if I plot that point, and then I use the slope of up 3 over 1, up 3 over 1, I can draw that line fairly quickly. Just like that. This one here needs a little rearranging, so I'm going to add 2x to both sides and divide everything by negative 1. And then my slope would be negative 2, and my y-intercept would be 0, 8. So if I start at 8 and I'm going down 2, right 1, down 2, right 1, down 2, right 1. Okay, that would be my second or line, and then my last one, x equals 6. This is one of our special cases. This tells us that every point on the line has an x value of 6. That means here 6, 6, 6. All of these have x values of 6, and what we should notice, that is a vertical line. Okay, a couple of multiple choice questions. So Louisa chooses a cell phone plan that charges a flat fee of $20 per month. So that right there is a keyword, flat fee. We want to know what that means. And 25 cents for each text message sent. Okay, so if we look down here, we're looking for which equation best represents this. So something with a flat fee, we've looked at, it's going to be a partial variation. So we need to have adding of $20 somewhere in there. And then we have to keep track of the 25 cents for each text message. So the first two can go because they have no adding. C has adding, but it's adding 25 cents and not adding $20. So C is out, so the answer is D. There's the flat fee, there's the 25 cents per text message. Okay, next one. There is a linear relationship between the total cost of renting a costume and the number of hours the costume is rented. That information is given there. So this is a classic example of a pairs of information question. So I'm going to make a little table. So we have time, we have dollars. If I list that information on there, it helps me organize my thinking. Okay, so now what type of variation is this? So we're looking for either partial or direct. Now if we read through these answers, we can get rid of the bottom two pretty quickly because it says a direct variation with an initial value of $30. Direct variation always goes through 0, 0. So those two are both out. Okay, just by virtue of they conflict within its own sentence. So if we looked at these ones here, we can see there is a rate of change of 2 and $20. So my rate of change would be $20 every 2 hours or $10 for 1 hour. Okay, now I can use that information and work backwards. So if I work backwards to 2, 1, and then 0, these are all going to go down by 10. And there is my y-intercept. So this is a partial variation for sure with an initial value of $30. Okay, have a look at this one. Pause it if you need to. So two lines are shown. Which of the following describes a difference between line 1 and line 2? Line 2 has a larger initial cost. Well, there's the initial cost. That's our y-intercept. It's the same for both lines. So line 2 has a larger initial cost and line 1 has a larger initial cost are both incorrect because they have the same cost. Line 2 has a greater rate of change, or line 1 has a greater rate of change. Remember, this is slope. So line 1 has a greater slope. It's steeper. So D is the correct answer. Which of the following equations is equivalent? That means equal. So everything listed here is in the form y equals mx plus b. So we want to do a little bit of work here and rearrange this. Divide everything by -5, and we should get something that looks like that. And now we can come over to the multiple choice answers and compare. So I can get rid of C and D pretty quickly. Now I'm looking at A and B, and I want to just double check my signs. So it looks like A has a positive slope and a negative y-intercept. There's my answer. Okay, so which equation below represents a line that is perpendicular to the line represented by y equals 3x minus 5? Well, the first thing I would do is I would write down the slope of this line. The slope is 3. And then I would take a second and figure out what is perpendicular to 3 over 1. Okay, well, perpendicular lines have negative reciprocal slopes. Okay, so we would expect this slope here to be the reciprocal and negative. Okay, so now I'm looking over here on A, B, C, and D for one of these lines to have a slope that's a negative 1/3. So A is out, B is out. Now I have to look very carefully at C and D, and C is the only one which has a negative 1/3, so C is my answer. Okay, this one looks like a big question, but it's not as bad as it looks. Lucia and Paul each have a plant. Both plants grow at a constant rate. That's an important piece of information. Lucia records information about the height of her plant in a table. Paul records this in a graph. Okay, so if we look at this, Lucia's plants, if we take a quick look at what the rate of change for her plants are, this is changing by 3, this is changing by 2 centimeters. So Lucia's plants are changing at 2 centimeters every 3 days, which is about 0.67 centimeters a day. Okay, and if we look at Paul's, I'm going to draw a line on here and make a triangle. So I'll make this thing a little thinner so it's a little easier to see. Okay, so now if we take a look at Paul's information, and we have to be very careful on this because we can't count squares as being 1 each. They're worth a little bit more. Okay, so this value right here, this is a 10, and this value here is a 22. So this is a run of 12 days. This is a starting value of 7 and a finishing value of 19. So that is a rise of 12 centimeters. So the rate of change or slope for Paul would be 12 centimeters in 12 days, which means Paul's rate of change is 1 centimeter per day, which means Paul's plant is growing faster, and you can justify it by virtue of those calculations. Okay, last one. The graph below represents the relationship between the amount of water, A, in a pool as it drains, and time T. So the first thing I do when I see a question like this is I'm going to fill in some missing information to help it seem or look a little easier. So determine the initial amount, so there's y-intercept, and the rate of change, so there's slope. So right away when I look at this, if I look at that graph, I know my slope is negative because it's going down from left to right. I'm going to write the location of a couple points on here. This is 70, 0. This is 20 and 45,000. And then I would do like I always do. I set up a table of values. This is time. This is amount of water. And I get that information onto a table because I find that very easy to help organize how I'm thinking. Okay, so now if I want to find, I'm going to go after the rate of change first because I can do this. This is changing by 50 minutes. This is changing by, and please note the negative sign, negative 45,000 liters. So your rate of change is negative 45,000 liters every 50 minutes. Okay, which means my rate of change, if we actually do that division, is negative 900 liters per minute. That means we're going down 900 liters every minute. So we have our rate of change. Now why it's important to have that is that we can use that information to work backwards. Okay, so if I want to get to 0, or our initial value, our y-intercept, I am changing by 900 liters every minute, but I'm using 20 minutes, so I have to have a change of 18,000 here, which is 20 times the 900. Okay, and I can't fit the negative sign in there, but you can see it there. So whatever number I have up here, I subtract 18,000 from it, and I get to 45,000. So we should find the number that's missing, I think is 63,000 liters. So if I started with 63,000 liters, after 20 minutes it's gone down 18,000, and I'll be at 45,000. So the initial amount is 63,000 liters. Okay, thanks for tuning in. That's your quick review.